right, today we are going over the test review for the sum and difference identities and also our double angle identities. We'll also be solving some trig equations and doing some inverse trig calculations. Before we get started, please make sure that you have a list of the sum and difference identities. We're going to be using them for about half of the review. If you don't, go ahead and pause the video right here and write them down. You'll need to have them in front of you so that you can reference them as we go through the review. Same thing for the double angle identities. If you don't have a copy of them, please pause the video right here and write them down so that you have them in front of you to reference as we go through the review. All right, we're going to start with question 1. It says use the sum and difference formulas to find the exact value of the following. And so we are going to use sum and difference identities to find the exact value of sine of 5 pi over 12. Now, remember that we had you convert the radian angle measures to degrees. And so we're going to go ahead and do that right now just to sort of refresh our memory. 5 pi over 12 can be converted to degrees by multiplying by 180 over pi. And when we do that, the pi's cancel out, and then 180 is also divisible by 12. You get 15 when you do that division. And so this ends up being 5 times 15, which is 75. So sine of 5 pi over 12 is sine of 75 degrees. And I do not know the sine of 75 degrees, but I can break 75 down into two angles that I know the sine and cosine and tangent of. And those angles are 30 degrees and 45 degrees. So this is sine of 30 degrees plus 45 degrees. And so now what I can do is I can use the sum identity for sine to find the numeric value for sine of 75 degrees. So sine of 30 degrees plus 45 degrees is equal to sine of 30 degrees cosine of 45 degrees plus cosine of 30 degrees sine of 45 degrees. And I do know sine and cosine for both 30 and 45 degrees, so I'm going to evaluate that trig function at those numbers. So sine of 30 degrees is 1/2, and cosine of 45 degrees is root 2 over 2. Then we're going to add cosine of 30 degrees is root 3 over 2, and sine of 45 degrees is root 2 over 2. And so then I'm going to multiply the 1/2 and the root 2 over 2. And when I do that, I get the square root of 2 over 4. And when I multiply the square root of 3 over 2 times the square root of 2 over 2, I get the square root of 6 over 4. I can't add the root 2 and the root 6, so I go ahead and leave them separated. So this is the square root of 2 plus the square root of 6 over 4. And that's our answer. So sine of 75 degrees is root 2 plus root 6 divided by 4. All right, we are going to use either a sum or difference identity to find the cosine of 105 degrees now. On your paper, you have 7 pi over 12. I went ahead and converted to degrees just to save time. So cosine of 105 degrees, I don't know the cosine of 105 degrees, but I do know cosine of 30 degrees, I know cosine of 45 degrees, and 60 degrees, and 90 degrees. So I can write 105 degrees as cosine of 60 degrees plus 45 degrees. And so I can use the sum identity for cosine to find the cosine of 105 degrees. So cosine of 60 degrees plus 45 degrees is equal to cosine of 60 degrees cosine of 45 degrees minus sine of 60 degrees sine of 45 degrees. And I can evaluate both cosine and sine at 60 degrees and 45 degrees. So cosine of 60 degrees is 1/2. Cosine of 45 degrees is root 2 over 2. And sine of 60 degrees is the square root of 3 over 2. Sine of 45 degrees is root 2 over 2. And you may or may not notice that this looks an awful lot like the last problem we did. And all of these problems sort of look like each other because we're using the same angle measures to find the sine or cosine of, an angle measure we don't know. So you're always going to be using the 1/2 and the root 2 and the root 3 to find these angle measures. So all of our answers will sort of look kind of in the same family. So 1/2 times root 2 over 2, that's the square root of 2 over 4. And then this is minus the square root of 6 over 4. And again, I cannot combine the root 2 and the root 6, so I leave them separate. So this is the square root of 2 minus the square root of 6 divided by 4. And that's our answer. So cosine of 105 degrees is root 2 minus root 6 over 4. Now we're going to find the tangent of 105 degrees. Again, I've converted this angle measure to degrees already. And we could certainly use 60 and 45 like we did on problem 2. But I thought it might be good for us to use a difference identity. And so we're going to use a difference identity, and we're going to use tangent of 150 degrees minus 45 degrees. And just for reference, 150 degrees is a multiple of 30 degrees. It is actually 5 pi over 6. It's over there on the unit circle on the left side. And tangent of 150 degrees is negative root 3 over 3. It's negative 1 over root 3. And then when we rationalize, we get negative root 3 over 3. All right, so tangent of 150 degrees minus 45 degrees is equal to tangent of 150 minus tangent of 45 over 1 plus tangent of 150 tangent of 45. And so when we plug in our values for that, that's negative root 3 over 3 minus 1, because tangent of 45, remember, that's our favorite angle. Tangent is 1, and sine and cosine are both root 2 over 2. And then that's over 1 plus negative root 3 over 3 times, again, tangent of 45 is 1. And so we end up with negative root 3 over 3 minus 1 over 1 minus the square root of 3 over 3. Now, we've done the substitution part of it, but we do need to simplify this. And so we are going to have to find a common denominator. And so for the numerator, the common denominator is 3. It's the same for the denominator. So those 1s become 3 over 3 when we multiply by 3 over 3 to get a common denominator. So what we end up with is negative root 3 over 3 minus 3 over 3, and that's again our 1 that we've made into a fraction so we can combine them. And this is 3 over 3 minus root 3 over 3. And so we get negative root 3 minus 3 over 3 divided by 3 minus the square root of 3 over 3. And so now I've got one fraction in the numerator and one fraction in the denominator. And what I'm going to do is I'm going to divide. And remember, dividing by fractions is easy as pie. You flip the bottom and multiply. So this is negative root 3 minus 3 over 3 times, and now I'm flipping the bottom, so it's 3 over 3 minus root 3. And when you do that, you get that these 3's cancel out. The lone 3 in the denominator, the lone 3 in the numerator, they cancel out. You get negative root 3 minus 3 over 3 minus root 3. And you can certainly leave your answer there. If you were going to rationalize this, we would multiply by the conjugate. So 3 plus the square root of 3, multiply the top and the bottom by that conjugate. I do notice that we have a negative root 3, a negative 3, and a negative 3 there. And so I might say this is the square root of 3 plus 3 over the square root of 3 minus 3. And so what I did is I switched the signs on all the pieces so that both parts of our numerator are positive. And so I made this root 3 in the denominator positive and the 3, the whole number 3, negative. So I just switched the signs on everything. Certainly either answer is correct, but you should be able to recognize the similarity between these two answers, that those two answers are actually the same answer, just written in two different ways. Either of them works. All right, guys, the next couple problems deal with already expanded sum and difference identities. So instead of taking an angle and having to write it as multiple angles, we are given multiple angles and we get to condense them down into one. So for number 4, I'm looking at this and I see that this is the sum identity for sine. So this is sine of 20 plus 10 degrees. And that's sine of 30 degrees. And so sine of 30 degrees is 1/2. And so we're done. That's all we had to do, was put those two angle measures together and then evaluate. Again, with the cosine, I noticed that what I have is the difference identity for cosine. So this is cosine of 40 degrees minus 10 degrees, which is cosine of 30 degrees. And cosine of 30 degrees is the square root of 3 over 2. And that's all we have to do. So these guys look crazy pants and complicated, but they're actually the easier problems to work through. All right, I've got two tangent identities here. And so this is the sum. Number 6 is the sum identity for tangents. And so this is tangent of 20 degrees plus 25 degrees, which is tangent of 45 degrees. And we love finding tangent of 45 degrees because it's just 1 and we are done. Number 7 is the difference identity for tangent. So this is tangent of 40 degrees minus 10 degrees. And that's tangent of 30 degrees. And tangent of 30 degrees, we were just working with that for problem 3. That is the square root of 3 over 3. And so we're done. All right, guys, for number 8, they are expecting us to use given information, sine of an angle alpha and an angle beta, to find sine of alpha plus beta, cosine of alpha plus beta, and tangent of alpha plus beta. And so in order for us to find all 3 of those things, we have to know sine, cosine, and tangent for these 2 angles, alpha and beta. Now this is a throwback to the triangle trig that we were doing earlier in the year, where you were asked to find the third side to a right triangle and then use our knowledge of angle location and side length to find sine, cosine, and tangent. So I'm going to remind you of our SOHCAHTOA. Just to remind you of the relationships between sides and angle measures. And so if I have sine of alpha, they've told me that it's between pi over 2 and pi, and that means it's between 90 degrees and 180 degrees, and that means it's in quadrant 2. Okay, and so if I draw just a rough sketch, my angle alpha is over here. Now remember, sine is opposite over hypotenuse, and so my opposite side is 4 and my hypotenuse side is 5, and we can find the third side by using the Pythagorean theorem. So a squared plus 4 squared is equal to 5 squared. So a squared plus 16 is equal to 25. A squared is equal to 9, and a is 3. And you guys should have all recognized that A was 3 because we have worked with this 3, 4, 5 special right triangle multiple times in the last few days in class. Now, this 3 is negative, and that's because we're in the second quadrant, so we're on the negative side of the x-axis. So the 3 is negative. Now, what I can say about alpha now is that I know that sine alpha is 4/5. They gave that to me, so I knew that. Cosine alpha, so adjacent over hypotenuse, cosine of alpha is -3/5, and tangent of alpha is opposite over adjacent, and so that is 4/3, and that's negative because the 3 is negative. And so now I have my sine, cosine, and tangent values for alpha. And I can use the same process to find sine, cosine, and tangent for beta. Now they told me beta is between pi and 3 pi over 2. That's 180 degrees and 270 degrees, and that is quadrant 3. So beta is down there in the third quadrant. And they told me sine of beta, so again, opposite over hypotenuse, is 2/5. The 2 is negative because we are in the place where both x and y, sine and cosine, are negative. So the 2 is negative. And I can find the third side there by saying, again, a squared plus -2 squared is equal to √5 squared. So a squared plus 4, because remember -2 times -2 is +4, is equal to 5. A squared is 1, which means A is 1. And so this missing side length is -1. That's the side we were looking for. Now what I can say now is that sine of beta is negative, not square root, -2/5. And that's what I was given. Cosine of beta is adjacent over hypotenuse, so -1/5. And tangent of beta is the opposite over our adjacent, so it's -2 over -1, which is just 2. All right, so now we're going to find sine of alpha plus beta, cosine of alpha plus beta, and tangent of alpha minus beta. All right, so this sine of alpha plus beta is sine of alpha cosine of beta plus cosine of alpha, that's not alpha, sine of beta. So then what I do is I use the values I found using the unit circle and just plug those in. So sine of alpha is 4/5. Cosine of beta is -1/5 plus cosine of alpha is -3/5, and sine of beta is -2/5. And so this is -4/5√5 plus 6/5√5. And that simplifies, the 5√5 are common denominator, so that simplifies to 2/5√5. And that is our answer. So we just find those trig values that we used the triangles for, and we just plug them right in. So cosine of alpha plus beta is cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And I have those values. So cosine of alpha is -3/5. Cosine of beta is -1/5 minus sine of alpha is 4/5. And sine of beta is -2/5. And so that is 3 over 5 root 5 plus, because of this negative here and the negative on the 2, so plus 8 over 5 root 5. And that is 11 over 5 root 5. And so cosine of alpha plus beta is 11 over 5 root 5. All right, the last thing we're going to find is tangent of alpha minus beta. And that is tangent of alpha minus tangent of beta over 1 plus tangent alpha tangent beta. And so we're going to plug the values we found in and simplify. So tangent of alpha is negative 4/3. Tangent of beta is 2. And then this is 1 plus negative 4/3 times 2. Now I do need to find a common denominator for both pieces of my fraction. So this is negative 4/3 minus 6/3. That's 2, right? 6 divided by 3 is 2. All right, and then for the base here, negative 4/3 times 2 is negative 8/3. So this is 3/3 minus 8/3. And so we end up with negative 10/3 over negative 5/3. And remember, dividing by fractions is easy as pie. You flip the bottom and multiply. So this is negative 10/3 times 3 over negative 5. And that's negative 10 over negative 5, which is just 2. And so the answer to this problem is just 2. Isn't that exciting? All right, now for number 9, they've given us that sine theta is 3/5. And then they want us to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So these are double angle problems. I'm going to be using those double angle identities, all right? I am going to start this problem the same way I started number 8, where I use a triangle to find cosine of theta and tangent of theta. But when we go to use identities, again, we're using the double angle identities because we have 2 theta in all of our parentheses. So they've told me that this angle theta is between 0 degrees and 90 degrees. That's 0 and pi over 2. And so when we put that on our graph, that's where this triangle is. This is theta. And remember again, SOHCAHTOA, right? That's again something you should have written down so that you have it, for every one of these problems we do as a reminder. So sine is opposite over hypotenuse. That's 3 over 5. And we know then that the third side is 4. So sine of theta is 3/5. They gave that to us. Cosine of theta is adjacent over hypotenuse, so 4/5. And tangent of theta is opposite over adjacent, so 3 over 4. All right, and now we're just going to use the double angle identities that we learned and these values of theta to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So sine of 2 theta is 2 sine theta cosine theta. So for this problem, that is 2 sine theta cosine theta. And sine theta is 3/5, so 2 times 3/5 times cosine of theta is 4/5. And so that's 2 over 1 times 12 over 5. That's 24/5. And that's our answer. And so it is just that simple to work this out. When you have those sine and cosine values, it's super fast to work these problems. All right, cosine of 2 theta. Remember, cosine's the one where we have 3 separate identities that we can use. It does not matter which one we use. I'm just going to use the 1 minus 2 sine squared. of theta. And remember that that sine squared applies to the whole thing, sine of theta, quantity squared. So remember that when we start working it out. So this is 1 minus 2, and then sine squared of theta. So sine of theta is 3/5, and we're going to square that. So we get 1 minus 2 times 9/25, which is 1 minus 18/25. And of course, we do need to find a common denominator here and simplify. So this is 25 over 25. That's the 1, right? 25 divided by 25 is 1. It's the 1 from our problem, minus 18 over 25. And that is 7/25. And so that is our answer there. All right, last one is tangent. And tangent of 2 theta is 2 tangent of theta over 1 minus tangent squared theta. And so when we plug in our values, that is 2 times 3/4 over 1 minus 3/4 squared. And so that is 6 over 4 over 1 minus 9/16. Again, we do need to find a common denominator for the base of this fraction. So 1 is 16 over 16. And so we have 6 over 4 over 16/16 minus 9/16. That's 6/4 over 16 minus 9 is 7/16. And remember, dividing by fractions is easy as pie. Flip the bottom and multiply. And so when we do that, this 4 is gone, it becomes 1, and the 16 becomes 4. And so you end up with 24/7. And we're done there. That's your solution. All right, guys, 10 through 14 are solving trig equations. And remember when we do this that we first find what we call a general solution, and then after that we deal with our specific solutions. Now for 10 through 14, all of them, we were given the interval 0 is less than or equal to theta is less than or equal to 2 pi. And so our solutions need to be between 0 and 2 pi, or in degrees, which is how we're going to solve these, between 0 and 360 degrees. And so we'll find our general solution, which will tell us the solution no matter what, and then we'll only choose the solutions that are between 0 degrees and 360 degrees. So for number 10, the way we do any of these is we get the trig function alone, and then we ask ourselves, all right, if that is what the trig function is equal to, what is the angle where that happens? So to get the sine theta alone, I divide by 2, and I get sine theta is equal to root 3 over 2. And so right now what you should be doing is referencing your unit circle or your table of values so that you can tell me what are the angle measures where sine is equal to root 3 over 2. Now, if you are referencing your unit circle or your table of values, you know that theta is equal to 60 degrees. And also, because it's positive root 3 over 2, we're also looking at 120 degrees. Now, those are just the first two solutions. Remember that we are looking at 60 and 120, but then we also look at every iteration of those angles. So every time we go around the circle, we're looking at the position 60 and the position 120. And the way we say that is we say 60 degrees plus 360 K, and 120 plus 360 degrees times K. And K is the number of times around the circle you've gone. So these are our general solutions. And if we did not have an interval, that's what we would expect, is the general solutions. Now, because we've been given an interval, we have to stick to the angles between 0 and 360. We're going to take those two general solutions and we're going to find the specific solutions that fit that interval, 0 to 360. So we're looking between 0 and 360. So what if K is 0. Then theta is 60 degrees and theta is 120 degrees if k is 0. What if k is 1? Then we'd have theta equals 60 degrees plus 360 and 120 plus 360. And because we are stuck between 0 and 360, these solutions for k equals 1, we throw those out. Those don't work. And so for number 10, the solutions are theta is equal to 60 degrees and 120 degrees. And only those two solutions. All right, so we're going to solve 11 the same way. We're going to get the trig function alone. So the first thing we're going to do is add 1 to both sides. So I've got 2 sine squared theta is equal to 1, divide by 2. Sine squared theta is equal to 1/2. And then to get the sine alone, I've got to take the square root of both sides. And so sine of theta is equal to, that's the square root of 1/2 or the square root of 1 over the square root of 2. Square root of 1 is just 1, so this is 1 over root 2, and we don't recognize that value, or maybe you do, but not everybody recognizes it. That's okay, but if we rationalize, you get root 2 over 2, and we recognize that value. That's 45 degrees, right? Sine of 45 degrees. Now the question is there another angle that works for? So theta is equal to 45 degrees, and theta is also equal to 135 degrees because we're talking about sine. So we're talking about the two angles above the x-axis. Now, those are specific solutions, but we want general solutions. We always start with our general solutions. So 45 degrees plus 360 degrees times k. And again, k is the number of times we have circled the unit circle. So the number of times we've gone around the circle, that's k. So these are our general solutions. If we did not have an interval attached, those would be our solutions. What we need to do now is we need to say, okay, but I'm looking between 0 and 360. So if k is 0, let's test that, then theta would be 45 and 135 because those 360s cancel out. All right, what if k was 1? And so this theta would be 45 plus 360 and 135 plus 360. And again, like with the last problem, I can throw the k equals 1 values out. I can just get rid of them. And the reason is that this 360 is going to guarantee that they're above the upper limit of my interval. And so I am only looking at the first two solutions again. So theta is equal to 45 degrees and 135 degrees. And remember, they gave us this interval 0 to 360 for all the problems, 10 through 15. And so we're going to be using that interval for, we used it for 10 and 11. We're going to use it for the rest of the problems in this section on solving trig equations. All right, let's look at tangent squared of theta is equal to 1/3. That's number 12. The first thing we do is get the trig alone. There's nothing to add or subtract, but we do need to take the square root of tangent squared theta and the square root of 1/3. And so I've got tangent of theta is equal to the square root of 1 over the square root of 3. And we know that the square root of 1 is 1. We don't know the square root of 3. And again, that may not look right away like something that an angle measure for. But remember, if you rationalize, this is root 3 over root 3, we multiply. And so you get tangent of theta is equal to root 3 over 3. And that's the rationalized angle. And we know that then theta would be 30 degrees. And remember that for tangent, the period of tangent, the cycle for tangent is 180 degrees. And so instead of adding 360, we're going to add 180. And so we're looking at just movement through the first two quadrants. So we add 180K. Again, that's because the period of tangent is only 180. It's pi in length. And so when we add the period. And so in this case, it's 180. Sine and cosine, you add 360. Tangent and cotangent are the only ones that you add the 180 for. And again, this is my general solution. I am still, for this problem, looking between 0 and 360. And so when I look at this, I say, all right, well, what if K is 0? And so theta would be 30 degrees. All right, what if K was 1? Well, theta would be 30 degrees plus 180. And that's 210 degrees. That fits into my interval. That works. That's fine. What if K was 2? That would be theta is equal to 30 plus 360. And again, now we have exceeded the upper boundary of our interval, and so we can't use that angle measure. So theta is equal to 30 degrees and 210 degrees for this problem. All right, 13, 14, and 15 are a little more complicated because they have 2 theta or theta over 2 or 3 theta. Now, I know that your impulse here, because we've just been doing the double angle identities, is to say, oh, it's a double angle, but this is just an equation. If you've got an equal sign, guys, if it's an equation that you are solving for theta, which is what we're supposed to do here, don't pull in a double angle identity. What we do is we solve this for the trig function, cosine, evaluate the angle measures where that happens, and then we use that 2 theta and we set that equal to the angle measures where this happens. So I don't have anything to do in terms of solving for cosine. Cosine is already alone. What I want to know is, what are the angle measures where cosine is 1/2? Where is cosine 1/2? Cosine is 1/2 at 60 degrees. And then it is also 1/2 again at 300 degrees. And that's in the first quadrant and in the fourth quadrant. And so the way we would write that, we would say theta is equal to 60 degrees plus the 360K, because we're looking at every turn around the circle. And then also theta is equal to 300 degrees plus 360K. And so now I know that's the angle, those are the angles where cosine is 1/2. But remember that I'm not just looking for theta, I've got 2 theta. I say 2 theta has to be the 60 degrees plus 360K. And 2 theta is equal to 300 degrees plus 360. And so we're going to solve for theta. So divide everything by 2. And we get theta is equal to 30 degrees plus 180K. Again, over here, we divide everything by 2, and we get theta is equal to 150 degrees plus 180K. And so these, again, are general solutions. They're my general solutions. I am, as always, with these problems, because they told me, looking between 0 and 360 degrees. And so I ask myself, okay, what if K is 0? The first angle is 30, and my second angle is 150. That fits into my angle range. I can be between 0 and 360. So that works. What if K is 1? So theta would be 30 plus 180. And over here, theta would be 150 plus 180. And so this is 210 degrees. That fits into my interval. And here, theta is equal to 330 degrees. which also fits into my interval. Now, if we go to k equals 2, then I've got 30 degrees plus 360 degrees. And over here, I've got 150 degrees plus 360 degrees because we multiply that 180 by 2. That is outside my interval, so that doesn't work. But for this problem, because we divided by 2, there are 4 angles. So theta is equal to 30, 150, 210, and 330 degrees. All of those angles. All right, 14 and 15 are done the same way. We look at this and we say, where is sine negative 1/2? What's the angle measure where sine is negative 1/2? So angles where sine is negative 1/2 are 210 degrees and 330 degrees. All right, and so then what we would do is we'd say, okay, well, theta over 2 is equal to 210 degrees plus the 360 times k, because again, we're looking at every revolution around the circle. Every time we go around the circle, we're looking at that position on the circle. And then also for the 330, theta over 2 is equal to 330 degrees plus 360 times k. And to solve these equations, what you would do is you'd multiply both sides by 2. So again, both of these equations, we're going to multiply both sides by 2. And here we get theta is equal to 420 degrees plus 720 k. And here we get theta is equal to 660 degrees plus 720 k. And when we remember our interval, And 0 is less than or equal to theta is less than or equal to 360. We look at these angle measures, the 420 and the 660, and we say even when k is 0, theta would be 420 and 660 degrees, and neither of those angles fit into our interval. Neither of them do. And so what we say here is, because none of those angles will fit into our interval, we say no solution. All right, last is number 15, and we're looking at where sine of 3 theta is equal to negative 1. The angles where sine is equal to negative 1 are at 3 pi over 2, and I know I've just slipped back into radians, guys, but sine theta is equal to negative 1 at 270, that's 3 pi over 2, plus 360 k, and that's the only place that sine is negative 1. So for us, 3 theta is going to be equal to 270 plus 360 k. And then we solve for theta. This is our general solution. We solve for theta, divide by 3. And so theta is equal to, this is 90 degrees plus 120 k. And so that's our solution for theta. It's again our general solution. And we remind ourselves that we're looking between 0 and 360 degrees. And so then we start plugging in k values and we say, okay, well, what if k is 0? Well, then theta would be 90. What if k is 1? Well, theta would be 90 plus 120. And that is 210 degrees. That fits into our interval, so that's fine. And then we say, okay, well, what if k is 2? Well, then theta would be 90 degrees plus 240 degrees. And that still fits into our interval. That's 330 degrees. So that works. And then we say, all right, what if k is 3? Then theta would be 90 plus 360 degrees. And now we are past our interval. Our interval ends at 360. This is too big, so we stop there. And so for us, for this problem, theta is equal to 90 degrees, 210 degrees, and 330 degrees. All right, these last two problems are really straightforward and simple, guys. We're going to use inverse trig and a calculator to solve them. So what you do is you get your trig alone. So for number 16, we're getting sine alone, and for number 17, we're getting cosine alone. So I do that by adding 2 to both sides. So 3 sine of theta is equal to 2. Divide by 3. Sine of theta is equal to 2/3. I do not know where sine of theta is 2/3. But what I can do is I can use the inverse trig buttons on the calculator to evaluate that and give me an angle measure. It's going to be a decimal. And so what we do is we say, okay, well, sine inverse of sine of theta, this is like taking the square root, is equal to sine inverse of 2/3. And you're using the sine inverse. It's in the trig menu on your calculators. When you do that, guys, you get theta is equal to 0.729727, and that's radians. Same process with number 17 and cosine. We subtract 3 from both sides. We get 4. Cosine of theta is equal to -3. Divide by 4. We get cosine of theta is equal to -3/4. And we don't know the angle where cosine is -3/4, but what we can do is take the inverse cosine. So cosine inverse of cosine of theta. And again, this is like taking the square root of something squared. And when we do that, we get theta is equal to 41.409622.